Good morning, dear students. Today we are going to see the Unit 2. In Unit 2, we have seen the two problems. One is the slider crank chain. The other is toggle mechanism. Now we are going to see 4-bar chain problem. Velocity and acceleration diagram we should draw in a 4-bar chain problem. I will read out the question. You please take it down. PQRS is a 4-bar link. PS is fixed. They are saying that PS is fixed. So PS is fixed. P and S are fixed. The length of the links PQ. They have given the length of the links PQ equal to 160. PQ is 62.5 mm, which is equal to 0.0625 meters. Okay, and QR is 175 mm. QR equal to 175 mm, which is equal to 0.175 meters, and RS equal to 112.5 mm, which is equal to 0.1125 meter, and PS equal to 200 mm. PS equal to 200 mm, which is equal to 0.2 meters. The crank PQ rotates at 10 radians per second. PQ rotates at 10 radians per second means they have given the angular velocity of PQ. The angular velocity of PQ. So we no need to find angular velocity of the PQ. They have given directly the angular velocity of PQ. Or otherwise they will give speed of the crank rotating in clockwise as some speed. Now they have given if they given the speed of the crank means we should find out the angular velocity of the crank. What is the formula for angular velocity of the crank? Omega PQ equal to 2 pi n PQ divided by 60. That is the value for angular velocity. Now they have given directly the angular velocity, so we need not to find angular velocity of PQ. They have given directly angular velocity of PQ as 10 radians per second. If suppose if they didn't give the angular velocity means they will give the speed definitely, so that we can use the formula as 2 by n PQ divided by 60. If we substitute the speed npq, you will get the 10 radians per second. That is the other way to find out the omega pq. Now clockwise, they have given that it will rotate in clockwise. They said that also. So draw the velocity and acceleration diagram at the angle QPS. Angle is given QPS equal to 60 degrees. They have given the angle of QP. QR lying on the same side of the PS. Here the Q value will come. So QR, where the other QR value, Q the value will be here and R value will be here, which lies on the same side of the PS. They have said that also in the question itself. Find the angular velocity and acceleration of the links QR and QR and RS. They are asking the angular velocity of omega QR. They are asking, and acceleration A or S. That's what they are asking to find out. To find omega QR and acceleration of RS. Okay, this both we can find using the.
Sir, is it for omega for both QR and RS, and acceleration
yes,
for
sir,
both?
Yes, sir. QR, omega QR means what is the formula? VQR divided by QR. That is the formula for to finding out the omega QR. Okay. Now we can proceed with the space diagram. Normally for a space diagram you should take a scale, because you can't draw 6.25 and 17.5 directly. We can't 175 mm. You can't. You are not able to draw this. So we have to take a scale ratio for drawing. Scale for space diagram. Space diagram. You should take a scale. Scale you can take it as 10 mm equal to 10 meters per second. Sorry, 10 mm equal to 1 centimeter. That means here the 10 mm is 6.25. If you draw means it will come as 160.62.5, and for this 17.5 mm means you will draw it as 175 mm. Okay, and for this 112.5 mm means if you draw 11.25 mm, it will come as 112.5 mm. If you take 200 mm means it will if you draw 20 centimeter means it will come as 200 mm. You consider this as a large scale means you can reduce the scale as 20 mm equal to 1 centimeter. You can reduce little bit smaller, so that if this you have to draw this means PQ you have to draw means 62.5 mm. 62.5 divided by 20. If you draw the scale means it will come as 62.5 mm. Sir, can you get me the scale ratio?
You need the scale ratio?
Yeah.
Or you need the scale? Okay,
Scale
it is 3.1. For
62.5
yes,
is
3.1.
3.1 centimeter means, okay, 175 mm divided by 20.
It is
Calculate this, sir.
8.25.
175 divided by 20.
8.75.
8.75 centimeter. 112.5.
5.6.
5.6 centimeter. 200 means 10 centimeter. Okay, that's all. First you have to draw 3.1 centimeter line. It is fixed, and we should mark an angle of 60 degree. Okay, from here you should take a pro circle and mark an angle as 60 degree, so that line will come like this. And the other point you have to draw 3.1 centimeter PQ as 3.1 centimeter, and Q point will come here. and the PS point is 200 mm, so that it will come as still much longer. I am drawing in the board. You are going to draw in a A3 sheet using drafter so that it will come accurately. Angle 60 degree. 60 degree. This is 3.1 centimeter. Your drawing Q value will come as 3.1 centimeter here, and now you are going to mark an arc of 5.6 centimeter. You are keeping the compass here and you are measuring 5.6 centimeter. You are cutting an arc and
5.6 centimeter.
So 8.75. You are measuring 8.75 and cutting an arc, and next you are measuring 5.6 and you are cutting an arc here, so that it will come as this point and this point, and this is the arc point. Okay, now the space diagram is over, and you should draw the velocity triangle using this space diagram.